Data analysis is an important step in research. Without analyzing the data, we can't find the result. Statistical method used in data analysis depends on the nature of the data. Chi-square test is a non-parametric test and which is used to find the association between two categorical variables, and it is also used to find the distribution of the one categorical variable. I am Dr. Jai Singh, and in this tutorial is made for understanding the concept of the chi-square test and also how can we use this test in social science research.
Dear viewers, in this video chi-square value will be calculated manually as well as with the help of Excel software. The aim is to make you skilled in hypothesis testing by computing the chi-square value using the test of independence for two categorical variables. So please watch the video up to the end.
I will show you how we use the chi-square test of independence. As we know, we use the chi-square test of independence if there are two categorical variables and we want to check whether they are independent, these two variables are independent, or in other words, if we are interested to find is there any association between these two categorical variables, then we use the chi-square test of independence. With the help of an example, I will show you how to find the value of the chi-square test manually. Suppose an example is given. A study was conducted on 210 students admitted in four courses to know their likeness of the assessment procedure techniques being adopted in their college. Students were asked to like one type of the assessment technique from seven categories, that is written assignment, test, presentation, quiz, viva, seminar, and online quiz. The frequencies are given in the following table. Are the course of study and the student likeness associated or dependent? And in this case, the frequency are given in this table, and the null hypothesis will be the course of the study and students likeness are independent or not associated, and alternative hypothesis will be the course of study and students likeness are associated or dependent. In this table the frequencies are given. For BA arts, the frequencies are 13, 9, 11, 5, 9, 6, and 7. Similarly, for the other courses, BA Social Science, BCom, and B.Ed, the frequencies are given, and the total number of the students are 210. As we know that the chi-square formula is chi-square is equal to summation of FO minus FE square divided by FE, where FO is the observed frequency and FE is the expected frequency. Now we see in this table, for BA Arts, written assignments frequency is 13 and presentation the frequency is 9, and similarly for other categories the frequencies are given. To find the expected frequency for BA arts student and in the written assignment, that is in this cell, how we find the expected frequency? For this we multiply the total frequency of the written assignment, that is here 45, and in this row the total frequency for BA arts student, that is 60, and divide by total frequency, that is 210. So for the first cell, we find the expected frequency by multiplying 45 and 60 and then divide by 210. In this way, we find the expected frequency, that is 12.86. Similarly, for the presentation and BARC students, that is in the second cell, in first row, we find the frequency by multiplying 35 and 60 and then divide by 210. And for the third test cell and BARC student, we find the expected frequency by multiplying 30 and 60 divided by 210. In the similar way, we find the other frequencies. And for the other courses like BA Social Science, first cell, the expected frequency we get by multiplying 45 in this column, the sum total of this written assignment column, multiplied by the total frequency 80 for the BA Social Science and divide by total grand total 210. And in the same way, we can find the expected frequency for all the cells. As we know that here expected frequency is written in bracket. Now we want to find the FO minus FA square divided by FA value in chi-square test for the BA Arts student. As we see that FO for the BA Arts student is 13 and FA is equal to 12.86. So first we find the difference, that is 13 minus 12.86 FO minus FA, and then we square it and divide by FA, that is 12.86. So we can see here for the BA Arts students, 13 minus 12.86 square divided by 12.86, and we get the value 0.001524. Similarly, for the other cell, we can find the value of F4 minus FA squared divided by FA by subtracting 10 from 9, that is 9 minus 10 is square divided by 10. And we can see that here in the second row it is written 9 minus 10 is square divided by 10. Similarly, for all the cell, we can find the F4 value of the F4 minus FA is square divided by FA for the BA Arts students. And in this way, we get these frequencies. And after this, we sum it, that is summation for the BARC student, summation F4 minus FA square up divided by FA. It means we sum 0.001524, 0.1, 0.68902 and other numbers, and we get the sum 1.470993. Similarly, for the other course, that is BA Social Science, we can get the value F4 minus FA squared divided by FA in the same way, and we get here 18 minus 17.14 square divided by 17.14. We can see it in the table for the BA Social Science. In the first column of and second row, it is 18 minus 17.14 square and then divide by 17.14. So we can see in this 18 minus 17.14 square divided by 17.14. And similarly for the other cells, we get F4 minus FA square divided by FA for the BA Social Science students. And after this, we add these values and we get the sum 2.21015. Similarly, we get for the BCom course, we get the value of F4 minus FE squared divided by FE. And for the BCom, we can check it in the table. For the BCom students, first cell, that is 10, is the observed frequency and 8.57 is the expected frequency. So we get the subtract it 8.57 from 10, 10 minus 8.57, we square it and then divide by 8.57 for the BCom students. So we can see here 10 minus 8.57 is squared divided by 8.57. So for each categories in the BCom, for the BCom students, we get F4 minus FA squared divided by FA, and we get these values. And if we sum it, then we find 1.91412. Similarly, for the B.Ed course, we also get the value of F4 minus FA squared divided by FA for all the categories, and we sum it and we find the value 6.207298. As we know, chi-square value is the sum of all f4 minus fa square divided by fa values. So we add these values for the all the four courses, that is BA Arts, BA Social Science, BCom and B.Ed students, and we get grand sum, that is 1.47 plus 2.21 plus 1.91 approximate value 6.20, and we get the value that is equal to 11.80256, and this is the value of chi-square. And if we check it by the table, but before checking it, first we should know about the degree of freedom. As we know, degree of freedom is the depends on the category, that is 7 categories are there. So row minus 1 multiplied by column minus 1. So here we write c minus 1 multiplied by r minus 1, and since there are 7 categories, so we subtract 1 from the 7, 7 minus 1, and 4 courses are there, so we subtract 1, 4 minus 1, and multiplied it we get 18, that is 6 3 and multiplied by 3 and we get 18. So the degree of freedom in this case is 18. And for the point zero 0.05 level of the significance, if we check, we find the critical value and we get 28.869, and we get it from the table. So if we compare it with the critical value, the chi-square value which we obtained in this calculation, we find the 11.80, and it is less than the critical value 28.86. So null hypothesis is accepted because it is not significant. If this value is greater than this, then only it will be significant and null hypothesis will be rejected. But in this case, since the value is less than the critical value 28.86, so null hypothesis will be accepted.
Dear viewers, thanks for your patience. In the second part of the video, you will see how to calculate the chi-square value in Excel. So please see up to the end of the video.
Now, with the help of an example, I will show you how we analyze the data using the chi-square test of independence in Excel. As we know that we analyze the data if its nature is categorical type and there are two categorical variables, and we want to find the association between these two variables, then we use the chi-square test of independence. In this example, a study was conducted on 180 students studying in school, graduate, postgraduate, and research levels. Their liking towards assessment procedure oblique techniques was asked. The contingency table for the frequency distribution is given. Are their liking to assessment procedure oblique techniques associated with the level of the study? Are their liking to assessment procedure oblique technique and level of the study dependent? If we want to check the dependency, or if we want to check the association between these two categorical variables, then we use the chi-square test of independence. Here in this table, in contingency table, seven categories of the assignments are uh, given, that is written, presentation, test, seminar, quiz, viva, and online quiz. This is the first variable, that is assessment technique, and the second categorical variable is the level, that is school level, graduate level, postgraduate level, and research level. Students belong to these levels, and uh, now we use this data in Excel. You can see that the observed frequencies are written here, and for the written school level 5, similarly 13, 8, 3, 7, 9, 19. And in the last column we have sum these frequencies, and their sum are 64. Similarly, for the graduate, postgraduate, and research students, the frequency are given, and also the sum of the first written column is 24, and the sum of the presentation is 25, and similarly the grand sum at the last is 180, which is calculated here. Now the main problem is to find the expected frequency. As we know that we can calculate the chi-square value by subtracting the frequency, that is expected frequency, from the observed frequency, and we square it and divide by the expected frequency and sum all these, we get the chi-square value. So in this example, the main problem is to calculate the expected frequency. Now first, for this cell, that is written and is school, we want to find the expected frequency. And for this cell, the expected frequency will be, first we see here, this is 5. So for this, the expected frequency will be calculated using this 64, that is the total for the school frequency, multiplied by 24, that is the sum of the written frequency, and divide by 180, that is the grand sum. So for calculating this, we write the formula here, and we write formula like this, equal, and we write the address of the cell. So we write B7 for 24, we write B7 multiplied by I3 for 64, I3 divide by grand sum, the address of the cell, that is I7. But before this, we make some cells, some address absolute. B7, there is no need to make its absolute, because if we drag it, then for the referencing style, others data will appear. So we do not need to make the B7 absolute, but I3 will be make the absolute. So for this, we write dollar symbol, dollar I, dollar 3, divide by dollar I, dollar 7, because in all the calculation I7 will be same. And for the first row, that is for the school, the value of I3 will also be same. So we make I3 and I7 absolute by inserting the dollar symbol, but the value of B7 will change for the presentation, test, seminar. Value of B7 will change with C7, D7 and E7 like this. So we do not make it absolute. Now click the enter button and we get the value 8.53. And now we drag it for the school row and we get the other value. Similarly, for the graduate, we calculate the expected frequency by clicking equal, and now we see for graduate is here. So the address will be B7 multiplied by I4. B7 multiplied by I4 and divide by I7. But in this address we need to make some cell absolute, so we insert dollar symbol before dollar 4 and $I dollar 7. In the same way as we have inserted this symbol dollar symbol to make the cell absolute, there is no need to make the B7 absolute because it will change. So after this we click the enter button and we get this value, and after this we drag it to get the other values in this row for the graduate. And similarly for the postgraduate, since postgraduate first cell is here, so for this we insert the address, that is B7 multiplied by I7 I5. Then we click equal, B7 multiplied by I5, but before this we insert dollar symbol, dollar I dollar 5, and we can see that these cell are selected and divide by dollar I dollar 7 and then click enter button. We get the value 3.2 and we drag it to fill the other values for the expected frequency. Similarly for the research, we click equal B7 multiplied by dollar I, and for this, for the research, the value, the address will be I6, that is dollar I dollar 6 dollar I dollar 6 divide by dollar I dollar 7, and we can check it that these cell are selected, and then we click the enter button and we get the value of expected frequency, and after this we drag it and the other value will be automatically filled. In this way, we find the expected frequency for all the cells. Now, we want to check whether the p value, what is the value of p, that is at which we will check whether it is significant or not. If the p value is less than zero point zero 0.05, then it will be significant, otherwise it will not be significant. For finding the p value, we click equal, and for this we click chi-square value, chi, and we select it, chi-square test, and we click it, and chi-square test, and we need to fill the actual range. Actual range means observed frequency range. We select observed frequency range, this, and leaving the total value, because observed frequency is only for the school graduate, postgraduate, and research, and for all the 7 categories. And after this, insert comma, and then expected range is required, that is the expected frequency. And for expected frequency, we select expected frequency and close the bracket, and then click. But before clicking it, first we check observed frequency is selected, and expected frequency is also selected, and then we click enter button, and we get the value 0.045, and this is p value. So we write p value is equal to 0.045. Since this value is less than 0.05, it means it is significant, and only when it will not be significant if its value is greater than 0.05 level of the significance. Because earlier, we should decide, first we should decide the level of significance, and suppose that we have already decided the level 0.05 significance. So the p value is less than 0.05, it means it is significant. And so we check the null hypothesis, that is assessment procedure and techniques, oblique techniques, and level of the study are not associated. Here, since p value is significant, so null hypothesis will be rejected, and the alternative hypothesis will be framed, and the alternative hypothesis will be assessment procedure, oblique techniques, and the level of the study are associated. In other words, we can say that assessment procedure, oblique techniques, and level of study are independent. That was the null hypothesis, it will be rejected, and against it, the alternate hypothesis will be accepted. That is, assessment procedure, oblique techniques, and level of the study are dependent to each other. So, by using the Excel and finding the p value, we judge whether null hypothesis is accepted or rejected. And in this case, the null hypothesis was rejected.